Hello everyone, in this video let's discuss about the power amplifier and their classifications. So if you see here, these power amplifiers are the amplifiers with high output power. They will be having the high output power, so impedance mismatch will be happening. So what impedance mismatch will do? It will help to get the maximum power, because these power amplifiers need the maximum output power, no? So this impedance mismatching helps to get the maximum power. And low output for the resistance, because when the resistance is low you can maximize the power. Now if you see here, I will draw the graph or the signal. So this is the signal I am taking. It may be the voltage or current signal, voltage or current signal. So if you see here, this is the positive half cycle and this is the negative half cycle. So this total height from the margin from here to here, it will be called as the amplitude. It will be called as the amplitude. Same in the case of the negative half cycle also. What these power amplifiers will do means they will amplify. Amplify means increase the height of the amplitude. So both in the positive and the negative half cycle, it will be called as the amplification. It will be called as amplification. These power amplifiers are used for the amplification operations. Now if you see the applications, it may be used in the speakers, radio, TV receivers. TV receivers means set-up box that you use to connect for the TV. So speakers, how they will means, if you have a mic, here I am having the mic. So why I am using this mic? To enhance my voice quality and increase the loudness of my voice so that you can hear correctly. So this amplification of my sound, what I am speaking through this mic, will be called as the amplification, and it will be done using the power amplifiers which are used in this mic. So if we see the types of the power amplifiers, we are having four types. First one is class A, second is class B, third one is class AB, and fourth one is class C. Now let's discuss all four of them separately. Now the first one is class A power amplifiers. Class A power amplifiers. Let us take the AC input signal, whether it may be of the voltage input or it may be of the current input. And in the middle we will be using the amplifiers. We will be using the amplifiers to amplify the amplitude. So this is the class A amplifier that I am using. So what this class A amplifier will do means, here I am having positive half cycle, negative half cycle, positive half cycle, negative half cycle. So this will conduct in 360 degree. So this will conduct in 360 degree means it will amplify both positive half cycle and negative half cycle. It will amplify both positive and negative half cycles. That is, it will increase the amplitude. This is positive, negative, positive, negative. So it will increase the amplitude of both positive and negative half cycles of the graph. So since it is the 360 degree condition, the transistor which will be used in the power amplifier, which will help in amplification of the sound or the given input, must be in the active region. Must be in the active region. When the transistor is in the active region, then only we can do the amplification operation. So you can tell that since it is having the 360 degree conduction, that is both positive and negative half cycle will be amplified. So you can tell the transistor will be in the active region for both positive and negative half cycle. Both positive and negative half cycle. Now, if we see the efficiency of the class A power amplifiers, it is about 25 to 50%. So, you can represent it using the neta symbol, which will be used to represent the efficiency. So, the efficiency of class A amplifier is between 25 to 50%. Now, second one is class B power amplifier. Class B power amplifier. Here the conduction will happen only for 180 degree. Only 180 degree conduction will happen. This is class B power amplifier I am using. So what it will do is, this will amplify only the positive half cycle because it is only conduction of 180 degree, no? So it will only amplify the positive half cycle and negative half cycles will be equal to 0. It will muffle the negative half cycle or reduce it to 0 and only amplify the amplitude of the positive half cycles. So you can tell that it is 180 degree conduction, and since there must be the transistor in the active region so that you can amplify the given signal, the transistor will be only in the active region for positive half cycle. Transistor will be in active region for only positive half cycle. So since it is only active in the positive half cycle of the given signal, it will conduct in a 180 degree. And if we see the efficiency of class B amplifier, so it is about 78.5%, which you can represent using the meter symbol. So its efficiency is 78.5%, which is more than the class A amplifier. Now let's move to the third one, that is class AB. In class AB power amplifier, it is the combination of class A and class B. So you can tell that the conduction will be between 180 degree, that is greater than 180 degree conduction, and less than 360 degree conduction. It will be between the conduction of the class A and class B amplifier. Class A amplifier conduction is 360 and class B is 180. So if we combine the class A and class B, so class AB will be the conduction of 180 degree to 360 degree. So you can tell that if this is the 180 degree, that is how you will represent 180 degree using pi. Next 360 will be using the 2 pi. Next again 3 pi. Next 4 pi. So what it will do is, so pi means 180 degree now. So it will be greater than 180 but less than 360. Greater than 180 but less than 360. Greater than 180. Greater than 180 but less than 360. And here also the negative half cycles will be muffled or equated to 0. So the transistor will be in the active region only for the positive half cycle here also. The negative half cycles value will be equal to 0 and the positive half cycles will only be amplified in the class AB power amplifier also. If we see the efficiency, since they are the combination of A and B, efficiency will also be between them only. So it will be greater than 50% and it will be less than 78.5%. Greater than 50% and less than 78.5% will be the efficiency of the class AB power amplifier. Now let's move on to the fourth one, that is class C power amplifiers. Now the last one is class C power amplifiers. I will be using class C amplifier, and here the conduction will be less than 180 degree. The conduction will be less than 180 degree in class C power amplifier. So pi means 180 degree, no? Less than 180 degree. Next again, less than 180 degree. Again, like that only. So it will also rectify the positive half cycles only and it will nullify the negative half cycles. So you can tell that the transistor will be in the active region only in the positive half cycle of the signals. And if you see the efficiency, class C has the more efficiency than all other three power amplifiers. So its efficiency will be greater than 90%. So if you see the efficiency which will be greater than 90% and it is more efficient than all other classes, that is class A, class B and class AB power amplifiers. So this was the brief explanation of power amplifiers. If you have any doubt regarding this topic, please do comment below. I will clarify it. If you like the video, please subscribe and support us because your one support motivates us to make more engineering related topic videos. Thank you.